Hello, everyone. Welcome to Start 1220 Elements of Statistics 1. Okay, so before we talk about today's lectures, I would like to do a recap on what we learned the last time that we met in class. And if I recall, we talked about measures of central locations. So given a data set, sometimes you want to locate the center of the data. How do we do that? So we have measures that will help us locate the center of our data set. So we talk about the mean, the median, and the mode. These are the three measures that will help us locate the center of our data set. So today we want to know the variability of our data sets. We want to know how spread or dispersed the data sets are. So there are measures that will help us determine the variability of our data sets. So these measures are the range, variance, and standard deviation. I believe you might have heard about this before. Okay. So the first measure of variability that we are going to talk about is the range. So by definition, we are saying that the range is equal to the maximum minus the minimum. So if you have a data set, locate your maximum, locate your minimum, give their difference, then you get what? The range. Note that the minus is there for the range. So if you have a minimum to be minus, still bring the minimum minus and bring the minus in the definition for the range. Okay. All right. So these are some examples for us to check. So by A, realize that the maximum number is 10 and the minimum is -1. So if we use the formula for the range, then it will be 10 minus, and the minimum is -1. So we bring the minus again. Note that very well because it's quite confusing. So it will be 10 minus -1. That gives us 11. So 11 is the range of our data set that we have for A. We do the same for B and C. Okay. Why is the range serve as a measure of variability? So the range gives us the interval for which our data sets are distributed. So a higher range means that these data are very dispersed. A lower range means that these data sets are very close to each other. So that helps us determine the variability of our data sets. The second one is the variance. So the variance, we have the population variance and we have the sample variance. So the population variance, we denote it by sigma square, and the sample variance is S square. So note their formulas very well. So we have the sigma square, we have the formula. In this formula, we have the total sample with no -1 in it at the denominator, but with the sample variance, we pick the sample size n, small n, and we subtract -1 from it. And the sample variance can be spread out to get another formula. But the first formula, you have S bar to determine. But the second one, you don't have any S bar to determine. Note that sum of S squared is different from sum of S all squared. Sum of S squared is different from sum of S all squared. The sum of S squared means that you pick each individual data point, you square it. You are going to get values. Sum all these squares. But the sum of S squared means that you sum all your data points, the answer you get, square it. So that is the difference. So each of them, so if you want to use the first one, then you need to determine what the sample mean, the sample mean. But if you want to use the second one, you don't need to determine the sample mean. You are good to go. Okay. And the sample standard deviation, okay, this will be the square root. If you have population variance, take the square root of the population variance, you get population standard deviation. If you have sample variance, take the square root of it, you get what? The sample standard deviation. That is that. Okay, so these are the three measures that will help us determine the variability of our data sets. Okay, so we have some examples for us to take through. So we have a box here, population data, sample data, and we have the letters that we've been using, their meaning, right, to explain what we've been using before. So we have a sample data, and we have to calculate what the range, the variance, and the standard deviation. So we are going to apply the formula that we've learned before to this data set. So this data set have 3, -2, 1, 0, -5, 3, 2, 0. So the range, the maximum is what? 3, and the minimum is -5. You give your subtraction, you get what? 8. Note it very well. The -5 comes, the range has its own minus in the formula. Bring the -5. Then you get 3 minus -5 and it becomes positive. That gives you 8. So that's the range. So the sample variance, we have what? S squared. If you use the first formula with what? The S bar in, it implies that we need to calculate S bar. Then, after calculating S bar, we subtract S bar from each data point that has been from each data point, then we square it. So, as you can see in this box with the red brackets, you can see that we subtract the mean from each of these data points, then we square it, then we sum it, then we divide by the total number of observations that we have, minus 1. So that is 8 minus 1. We get what? The sample variance. If you want to get a sample standard deviation, then we take the square root of our S squared. So the value we get for S squared, take the square root of it. You're going to get what? Your sample standard deviation. If you don't want to go through the stress, then by the calculator, we have a link on the Canvas page. It tells you, so you are going to input these numbers in the calculator, then it gives you the steps to calculate the mean and everything. So after that, just scroll down, you're going to get a lot of statistics. You have S with subscript S, we have sigma with subscript S. So S with subscript S is the sample standard deviation. Sigma with subscript S is what? The population standard deviation. Since when you take the square root of sample variance, you get sample standard deviation. And now we know the sample standard deviation, take the square of it, you're going to get the sample variance. And the same also applies to the population standard deviation. So if you have the population standard deviation, take the square of it, you get what? The population what? Variance. So that is how we do calculate these statistics if given. So example 2, note example 2. Example 2, we are given the population data. And in giving population data, it implies that we have to calculate the range, the variance, and standard deviation. So here, the variance, we are going to use all the n. We don't have to subtract 1 from it. The same applies to the standard deviation. So here, if you want to calculate the variance, then you have to use the sigma s. So the sigma s, you take the square of it, gives you the variance, and sigma s is the what? The standard deviation. So that is what you're going to choose for your answer. That is what you're going to choose for your answer. So I've demonstrated that here with the calculator, as you can see. Okay. All right. All right. Okay. So one last example so that we can conclude. So here we have been given, we have 10 employees and we took what? Their salaries. So the mean salary was 70,000, the median salary was 55,000. The standard deviation of these salaries were what? 20,000. The largest number on the list of the salaries, so the person that received the highest salary was what? $100,000. But by accident, this number was changed to $1 million. Okay, so if you have a list of salaries there, now what is the median salary after this change? So first of all, the highest list was what? The highest salary was 100,000. Now we change it to what? 1 million. Still, it will be what? The highest. And the median wouldn't be what? Affected, because since the maximum remains what? The maximum, it will still be what? 1 million. And we are going to have our median remaining the same. But what changed is what? Is the mean. Because since it has been increased from 100,000 to 1 million, $1 million, then it implies that our mean will also increase by a certain margin. How do we do that? By formula, we know that, let's assume so that we get, before you solve this question, let's understand something very simple so that we wouldn't get confused. Assume I have 1 and 3 as my data points, and I want to find the mean for these data points. Then I have to sum these two data points together. So we have S bar to be equal to 1 plus 3. And how many data points do I have? 2. So this gives me what? 4 over 2. And the answer is what? 2. So this, by the formula for S bar, we have S bar to be equal to sum of our data points all over what? N. Okay, so this implies that here the sum of our data points is 4, and our n is what? Is 2. If you do this, we get what? The mean. Okay, but by accident, I changed this 3 to 5. Note that the number of data points has not changed, so my n has not yet changed. But one of the numbers has actually what changed. This implies that my mean has to change. Okay, so how do I get it? Note that if I sum these, the first numbers, I get what? 4. But changing 3 to 5 means that I've increased 3 by what? 2. So if I sum these numbers, it wouldn't be 4 again. Now my new sum will be plus what? 2. And this equal to what? 6. This equal to 6. And I divide it by my n, which is what? 2. And this gives me what? 3. Okay? But the same thing applies. So if I cancel this and I have 1 and 5, then what is the mean? It will correspond to what? 3. So I have 1 plus 5 all over 2, which is what? 6 over 2, giving me what? 3. Okay? So this is the idea behind what you want to actually calculate. This is the idea behind. Okay, so giving this explanation to this very simple data set, how do we figure what we have in here? So here we have the mean to be 70,000. So we have S bar. Okay. So we have S bar to be 70,000. And know that S bar, the formula is what? Sum of S all over N. Okay. So this implies that we have 70,000 to be equal to sum of S all over what? N. Okay. And now what is N? That's the total number of employees that we picked. So our N is equal to what? 10. So how do we get our sum of S? If you're able to get our sum of S, we are good to go. So then therefore our 70,000, which is equal to the sum of S, will be divided by 10. If I want to get my sum of S, then I multiply here by 10. I multiply here also by what? 10. Okay, this cancels this. Then my sum of S will be equal to 10 times 70,000. And this gives me what? 700,000. Are we good? All right. So this is my sum of my data points. I have 700,000. And now there's one data point that has been increased. It is within it. It has been increased to what? 1 million. So by how much increase have we given to this sum of S? We've increased it by what? 900 what? Thousand. First it was 100,000 and it is 1 million now. It implies that this sum has been increased to what? 900,000. So we have to add the sum of S plus what? 900,000. And that gives us what? So that is 700,000 plus 900,000. And this gives us 1,600,000. Okay, so this will be our new sum. Our data points has not changed. It still remains what? 10. So how do we get the mean now after this change? Then we pick the new sum. That is what? 1,600,000. Then we divide it by what? N, which is what? 10. And this equal to what? 1,600,000. Okay, that gives us 160,000. 160,000. So this would be our new mean. Okay, that is that. So first of all, our first mean was what? 70,000. Now it has increased to what? 160,000 by the change. By the change. All right. Okay, so now we're on section 2.4. That is relative position of data. So there are ways in determining the relative position of the data. So we have the percentile, we have the quartile, Bose-Einstein plot, and the z-score. So we are going to go through this process. Okay, so the first is the percentile. So sometimes we have an observation in our data set, maybe S, and you want to rank this S in terms of percentages. So we do that by using the percentile rank of S. So, but before you do this, for you to rank this S, you have to rearrange your data from the smallest to the to the highest. Then you can rank your data, okay, in terms of percentages. So the percentile rank is equal to the number of data points at or below the point of interest. So if S in your data point is your point of interest, we don't know it, then